Hi viewers, in today's video we'll be solving some various inverse trigonometric functions. We'll be finding the derivative of them with respect to some other functions. And I'm sure you are right now familiar with how to find the derivative of inverse trigonometric functions. In case you are still not familiar with it, I'll drop the links, I'll drop the link of how to find the sine inverse, cos inverse, and the tan inverse in the description below. So let's just get down business. We have a lot of work to do. So for the first one, it's y is equals sine inverse of 3x. And we'll be using chain rule to solve this. I'm sure you are familiar with chain rule. In case you are still not familiar with chain rule, I'll make a video on it. Then you refer back to this so you balance your understanding. So chain rule, let me just write the formula. So we'll be using it. So chain rule, the formula for chain rule is dy, the x is going to be dy du multiplied by du dx. This is sometimes called the function of a function. So let's just get down to business. This is let u is equals 3x. You know, normally to pick your u, you pick the function that is inside the inverse function. So what is inside the inverse? It's what? 3x. So that is going to be your u. So we said let u is equals 3x, right? So immediately you get your u, get your du dx. What is du dx? If you differentiate 3x, you get 3. So after that, your function is going to look like y is equals sine inverse of, instead of 3x, I'm going to have u, right? So what is our dy du now? Because remember we did it in the formula. Our dy du is going to be, recall that I said sine inverse of x was minus, recall what I said? I said something like, I said the derivative of sine inverse of x was 1 over square root of 1 minus x square. I'm putting x square here because it's x here. So in place of this u, I'm putting 1 over square root of 1 minus, instead of x, I'm putting u because this time around it's u, not x. So I'm putting u square. So we have u, we have du, we have y, and dy. So we have everything we need for the formula. So how do you write it here? We have our dy, the x is equals, instead of dy du, I'm putting 1 over square root of 1 minus u square multiplied by du dx, which is 3. This can be rewritten as dy over dx is equals 1 times 3, that's 3 over square root of 1 minus, instead of u square, I have what u is already, right? My u is 3x. U square is going to be 9x squared. So I'm having 9x squared, and that's the derivative of the first question. So let's just go straight to the second question. For the second question, we have it to be y is equals sine inverse of, sorry, this is cos x. Just same idea. Sorry, I think I have to split the board. We'll just squeeze things down. So just same idea. We use the chain rule. Let u is equals, I said what is inside, which is cos x, right? So what is our du dx? Du dx is going to be, the derivative of cos x is minus sine x. We know that already, right? So we have y is equals sine inverse of, instead of cos x, I'm putting u, just like what I did here, right? So we have our dy over du this time. I guess that's what I did. Sorry, this place shouldn't be dy dx. Sorry, this should be dy du because I'm differentiating. Oh, not really here. Okay, I did the right thing. So dy du is equals sine inverse of u, which we said was 1 over square root of 1 minus u squared. So rewrite, I'm putting this in the formula. This is dy, the x is equals dy du, which is 1 over square root of 1 minus u squared times what is du dx? Our du dx was negative sine x. So to rearrange everything, our dy dx is going to be minus sine x over square root of 1 minus u square. But what is u square? Minus sine x over square root of 1 minus, instead of u, I'll put cos x. But what is cos x? What is u? U is cos x. Cos x square, because it's u square, I'm putting 1 minus cos square x, right? But something is still happening here. From the trigonometric identity we'll be using, when we have 1 minus cos square x, this is same thing as what? Sine square x. Recall from that, I guess I've been talking about this identity recently. When this crosses, it's still something. So in place of 1 minus cos square x, I'll just put sine square x. So we have our dy dx is going to be negative sine x over square root of, instead of this, I'm putting sine square x, which is equals minus sine x over, what's the square root of sine square x? That is sine x. Sine x cancels sine x, so that our dy dx is going to be minus 1. Wow, what an excellent result. Our result this time around is what? Minus 1. So going to the third one, which is the third example, it's like I'm running out of space. The third example says y is equals cos inverse of sine x. Same method, we let our u is equals sine x, right? So our du dx is going to be cos x. Then we have y is equals cos inverse of u. Then we have dy du is equals, remember, this is minus 1 over square root of 1 minus u square. From the last videos we've been doing, you will understand the derivative of the cos inverse of u. Then putting this in the chain rule, we are going to have dy dx is going to be dy du, which is negative 1 over square root of 1 minus u square, multiplied by du dx. What is du dx? Our du dx is cos x, right? So we have dy over dx is going to be negative cos x over square root of 1 minus, instead of this u square, I'm putting sine square. So I'm putting sine square x. So our dy over dx is going to be minus cos x over square root of, recall what I just did here. I was talking about, where is it? I was talking about the this same thing. Since I have 1 minus sine square here, I can just rewrite it with cos square x, because it's going to be something. When this goes here, this one comes here, I'm going to have cos square x, right? So this is equals minus cos x over square root of cos square x is something as cos x. Cos x cancels out. I'm having dy over dx is going to be minus 1 as well. Wow. That means we have the sine inverse of cos x is something as cos inverse of sine x. So I'm out of space to solve the, sorry, I have to clean this portion. It's just going to be a small work. Pardon me to use this. So for the first one, sorry, the last one, which is the fourth question, the fourth one, which is y is equals tan inverse of sine x, right? So we let u is equals sine x. Then we said our du dx is going to be cos x. Then we said y is going to be tan inverse of u. Then we have our dy du is going to be 1 over 1 plus u square. Don't forget what I said in the last video. I taught you guys how to find the derivative of the tan inverse of x. So it's something I applied there. In case you are confused about this, you can watch the video on how I got the derivative of the tan inverse of x. So this is dy du is 1 over 1 plus u square. So we can just insert all of this in our formula. What's the formula? Sorry, I still have to economize space. So the formula is dy dx, dy times dx is equals, in place of dy du, I'll be putting 1 over 1 plus u squared multiplied by du dx. What is du dx? Our du dx was cos x, right? So our dy over dx is going to be cos x over what is 1 plus u square. U was sine square x. Sorry, sine x. So I'm having 1 plus sine x, isn't it? Let's check it out. Maybe there's an error. We have dy dx to be 1 dy du, which is this, times our du dx. Our du dx was cos x. Then dy dx is cos x over 1 plus u square, which is sine, which is, this is supposed